Hey everybody, Motorama 2018 is around the corner, and I thought I'd talk a little bit about some of the changes I've made to Angry's weapon. Angry Accountant is a 1-pound robot I've been competing with for a long time, probably close to 15 years now. I've been using the same weapon setup and weapon shaft in particular all those years through all 3 variations of Angry, and I thought I'd talk about some of the changes I've made there. So here are the 3 generations of Angry. Angry 1.0, which only have this really left early blade, or actually this kind of mid-life blade. Angry 2, which was pretty successful, won a lot of different competitions. Copal for drive, Banebot speed controllers. Here's a state-of-the-art receiver from probably 2005 or so. Foam wheels, brushed motor. Here's Angry 3, which is more compact, much more aluminum involved. A lot prettier. This one and both of these actually had a lot of electrical tape involved. I would strap the batteries directly to the top. This used LiPo, but back in the day this had a short period of time where I was using NiCad or nickel metal hydride, and it was just ugly. But some pretty cool stuff. You know, to get upside down I could reverse the speed controller and do disco dance, and usually flip back up right side up.
I love that.
So what I want to talk about today is the weapon setup a little bit on Angry, because I'm making some changes for Motorama there. And so I kind of want to talk about how this works. This is the same axle pulley combination I've used for all 15 years. I've gone through a lot of different blade designs. This happens to be a 1-tooth style design. But I want to talk about some of the changes I made here and improvements and overall in both the axle, the pulley, and the blade. The same design's been used in all 3 variations in terms of the way that the bearings work. I have 2 ball bearings, one on each side. You can see here there's a lip in between that prevents them from sliding one way or the other, out this way or out the other way. And so this basically comes up through the bearings and bolts down to the top, so it can't come this way, and of course it can't come up this way. Same design, it's worked really well, and I'll go into the design of the pulley a little bit better in the axle. But in terms of the bearing setup, that's pretty much the exact same model I've used in all these different variations. So here's a better look at the weapon setup. Couple issues with this. This is a difficult piece for me to machine. It's one piece of aluminum 6061. I have a tiny Shoreline lathe that I made this on. It took probably at least a day to make, just because it's a little too big of a piece for the lathe. So very time consuming. It is also starting to bend with the more modern ant weights. Big hits will cause this axle to bend a little bit, so it doesn't lay exactly flat. That's why you can see some damage here where the blade started rubbing, because this would deform and allow collision. The other issue with this design is that there's these 4 holes here through the blade. They're tapped. They're number 6s. That can be challenging even on a annealed S7. I've broken a good number of taps while doing that, so I was hoping to eliminate these tapped holes just so I don't have to deal with that anymore. Also, because of those tapped holes, you can see there's a lot of meat around the central area there where those holes go through, and so if I could eliminate those holes, the hope is that I could get a little more, I could put that weight out farther toward the tips and improve my moment of inertia on the blade. The other problem with this particular design is it's designed for a round belt. I use those polyurethane make your own belt kind of things you can get from McMaster, and so it tends to slip a lot here, and eventually the belt melts or stretches, and it's just hard to keep the tension right. So I'm hoping to simplify this vastly so I don't have to keep making this. I want to make it out of something stronger so it doesn't bend. I want to eliminate these features here so that I can gain a little weight to put closer to the end, and I don't have to tap this damn S7. I also want to make sure this design is pretty straightforward so I can make it at my mill here in the garage rather than farming it out. So after some design work, this is what I came up with. This is all 3D printed, obviously, just to test some ideas out on other than this shaft. I'm going to do a quick building montage, and then I'll walk through the design features on this. So let's first talk about the changes in the weapon design. Here are the 2 weapons, the previous generation and the one I just made. No more screws, holes through there, no more tapping. There's a slot here for a pin, and I'll go into that a little bit later. You can see the moment of inertia has improved. I have more weight down here than I used to. This has also moved farther out. They weigh exactly the same, and I've effectively redistributed the weight here toward the ends to improve the moment of inertia, and I've avoided having to tap those damn holes. In terms of the axle and pulley, I broke this into two parts. I have a 3D printed pulley. It's an MXL timing belt style pulley to avoid that slipping. And since this is separate from the axle now, it's a much simpler matter to make this thing. This is just a steel axle. Tapped it with a 1/4-20 to lighten it a bit. Put some holes through it for pins that are going to retain everything. The bot's just going to ride on the nub of that there. A little concerned about how little material there is here, but hopefully there's not a lot of force going in that direction. So this all fits together with these pins. Put this pin in first, then press the blade down onto this. It's not going to be able to come off the bottom since that's just a slight indentation in the blade. After that, I'll put the next pin in, and the pulley will push down on top of that. There'll be a bolt here that keeps the weapon assembly from coming out of the bottom of the bot, and obviously you won't be able to go up through because of the blade and the pulleys and all that. I'll put it all together and give it a test spin up. Here's the finished product. You can see the pin there retaining the blade in place. There's also a pin holding the pulley so it can't spin freely. Should be able to just plop this directly in here. Real easy like. Come on, you son of a... Alright. Something's not right in terms of sizing. There we go. Ow. Get this guy in place. We're good to go. Have another timing pulley there, put the covers on, and I am ready for moto.